Friends, Naji here. Welcome to my YouTube channel. We know that nowadays we have a lot of data and a lot of big data, and analyzing, understanding and generating insight from those data is actually really challenging. Earlier we have a Hadoop MapReduce which was actually working well, but it has a lot of issues. One of the major issue is it has a lot of disk operations which actually reduces its performance. Now we have Apache Spark, and in this video we will be discussing on Apache Spark. What and why? So it's an open source distributed computing system. It's designed for big data processing and analytics, provide parallelism and fault tolerance, and it is providing the high speed and efficiency and very easy to use, which means that it will be supporting, or it is supporting like different programming languages like Scala, Python, etc. and it runs everywhere. Okay, we can run it in a locally, and you can run it in a cloud environment, and you can use the Kubernetes or most Yarn, anything you can use. And there are different data structures that we need to understand in Apache Spark, and in this video we will be discussing on the major two, that is RDD and the DataFrame. There are a couple more is there, but we will be only discussing these two data structures in this video. So resilient distributed dataset, and it is a foundational data structure. We can say that it is an immutable distributed collection of objects that can be processed in parallel. Okay, so that is RDD. So consider RDD as a list in the Python. Okay, but list is processing in a single node, right? But here RDD we can process in a multiple nodes. So that is advantage of RDD. Then the second data structure is DataFrame. Okay, so this is similar to our pandas DataFrame, or this look like our database tables, like it has a columns and it has a rows, etc. Okay, so this is built on top of RDD. So basic component, we have a Spark core is there. On top of that we have a Spark streaming component which will help us to do the streaming task, and we have a Spark SQL which can be, from name itself we know that it is used for the processing structured and the semi structured data. And we have a MLlib, so that is a machine learning libraries which will help us for the classification, regression and the recommendation engine. All those things we can do using MLlib libraries. And we have a GraphX which is used for the graph processing. So this is the high level component of Spark. And coming to the architecture, so basically it's a client server architecture. So we can understand this from this diagram, right? So we have a driver program, we have a cluster manager, and we have a different nodes. So in a high level, when we talk, whenever we have a program or whenever we have something to do, okay, then the driver program will divide that into small tasks. The task will be shared among different nodes. So each node have a executor, cache, and the task will be there. So that will be executed in parallel, and once that is execution done, which will be the result will be sent back to the driver program or to the server. And we have a cluster manager. The cluster manager is responsible for allocating the resources. As I said earlier, this can be a local cluster, or this can be a Kubernetes, or this can be a Yarn, or most anything. Okay, so that is how this works. Okay, now we can discuss what is there inside the driver program. Okay, so in the driver program we have a Spark context. Okay, so this is the little bit more detailed view of the Spark driver. So once we have a program, so we have a RDD graph is there. RDD we already discussed. So we will be creating some kind of RDD. Then we have a DAG scheduler is there. Okay, so what is the job of the DAG scheduler? Okay, so we can discuss that. DAG means direct asynchronous graph. Okay, so once we have a program, so DAG will divide that into different stages. Okay, consider here we have a stage 1, stage 2, stage 3 and stage 4, right? So this will be going to in a directed graph, like after stage 1 we will be going to the stage 2 and stage 3, stage 4, etc. But each stage will have a n number of tasks. Okay, so if we have like a multiple files, we can read those files in parallel, and filter operations also can be done in parallel, and map RDD also can be. So all those this tasks can be, or stages can be, or within the stage all those these tasks can be executed in parallel. Okay, so that is the job of a DAG. So DAG will divide into different stages, and within each stage we will have a multiple task. Okay, going back to a previous slide. So once we have a multiple tasks, now we need to execute that, right? So the DAG will coordinate with the task scheduler, and task scheduler will do this task in parallel, execute in parallel. For that it will be using the cluster manager to execute that into different nodes. Okay, so that is how this work, and the schedule backend, which will be mainly used to communicate with the cluster managers and the resource allocation. So that is how this Spark driver works. Okay, so these are the few points that we already discussed: Spark context, DAG scheduler, task scheduler, and the backend interface. Okay, so I will be attaching this to, I will be sharing this document with you. If you have time, just go through that. Okay, that's it. Then the common use cases, it will be used for the fraud detection, recommendation, and the predictive analytics. Okay, so that is about in this video. So we discussed the basic introduction and its architecture, and in coming videos we can discuss more about the Spark, Apache Spark. Basically we will be discussing more about in PySpark. We can do different programs and project, etc. So that's it. So please do like and subscribe. Have a nice day. Bye bye.